Hi students, these are your notes for 7.3 Law of Cosines. And what we're going to do in this first video is show you the proof for Law of Cosines. And that is only so you buy into the formula. You will never have to be tested on the proof. One thing I just want to go over before we start the proof is kind of what we've talked about so far. So far we talked about special right triangles. We can use that relationship when we have a 45, 45, 90, and it's a right triangle, or a 30, 60, 90 right triangle. Those relationships only exist with those special kind of triangles. So if I don't have those angles, I don't know what to do. So then we learned, oh wait, we can use these trig functions, sine, cosine, tangent, for right triangles to find missing values. And then we went into this world of, wait, what if we don't have a right triangle? We have an oblique triangle, and we learned about law of sines. Now, when I have an oblique triangle, my first go-to is to use law of sines because it is an easier formula to use. Now, it's only usable if you have a full ratio, and we might not have a full ratio. And that will make more sense in the next video. And that is when we have to go to law of cosines. And so for you to buy into this formula, let's go ahead with the proof. So I'm going to create an oblique triangle, and I'm going to label it any which way. I'd like to make that C a little bit bigger. And across from your A, that side length has to be little a. And across from big B would be little b, and then I know what I'm going to do to this side, so I'm going to show that the whole length here is little c. And now what I'm going to do is I'm going to go ahead and drop a perpendicular down from the vertex C. So what that means is that would form a right angle, and what that actually then turns out to be is the height of the triangle. Now we have here, what we've done is we've created two right triangles. So I have triangle 1 and triangle 2, just so it makes it easier to refer to. Now the other thing is I don't know what that altitude does to that base. I don't know if it cuts it in half, so I can't assume it. So I'm going to label this x. And then that other piece, well, that would have to be the whole minus the part. So that's why from here would be c minus x. And again, I don't know what that is. So then we have all of our pieces labeled. Now what I'm going to do is I'm going to use Pythagorean Theorem for that number 1 right triangle. We actually have 3 triangles here. We have 2 rights and 1 big oblique. So if I use Pythagorean Theorem for number 1, remember that would be leg squared plus leg squared equals hypotenuse squared. We know B is the hypotenuse because it's across from the right angle. So let's do the same for triangle 2. So that would be c minus x squared plus h squared equals my hypotenuse squared. All right. Now the next thing, and again, I just know where this is going, so that's why I'm just going to tell you to do it, is we're going to stand in triangle 1, and we're going to find cosine of A. Now we're looking in that right triangle 1. Cosine of A, remember the definition of cosine, and I can use cosine because it's a right triangle. That's adjacent over hypotenuse. And to guide us a little bit more, I'm going to isolate the x. So I get x is equivalent to b times cosine A. All right, well, what we have here are have this formula or equation, and we have this equation that might be helpful in the future. So what I'm now going to do is focus my attention on this Pythagorean theorem. So we have a binomial squared, so don't be cheap. Write it out twice so you can FOIL it. I call it being cheap when you just distribute that square inside. Okay, that's being a little lazy. We always have to write it twice and FOIL. So if we FOIL, we get c squared. Then we get minus, and it doesn't matter the order. I'm going to say cx. You could say xc. Then we get another minus cx. And then a negative x times a negative x is a plus x squared. All right, let's clean this up a little bit. These are like terms. So I get c squared minus 2cx plus x squared plus h squared equals a squared. So we have some equivalencies over here. We know x squared plus h squared is in fact equivalent to b squared. So you can substitute that in. We also know that x is equivalent to b times cosine a. And let me actually give them different colors so maybe they stand out. So I can substitute in these values since they're equivalent. You're not going to change the formula at all. So I get c squared minus 2c. Well, I have my x, which is b times cosine a. And then I know x squared plus h squared is in fact b squared. Now the nice thing is, and why I wanted to do that, is because my original oblique triangle did not have x in it. I created the x, right? So I wanted to get back to all the variables that my triangle had originally. This is in fact law of cosines. It's not given like that because they want to clean it up a little bit. So I write a squared on the left, and then what it is it's b squared plus c squared. So I'm not changing anything, I'm just rearranging terms, minus 2, and they're just going to go in order alphabetically, so they write BC cosine A. That is your law of cosines formula. You do not have to memorize this. This will be given on your formula sheet, and I'll bring that up, and I actually call it a reference sheet. I'll bring that up in the next video, but I'm just going to scroll down. Here is how your textbook gives it to you. And so they give it to you in terms of different variables. We'll talk about how to create those other ones right now and I'm not going to show you because it's the same proof. It's just if I wanted to get an equation for, c squared, let me go back down here, like this one, I would just drop my vertex or my altitude from a different vertex. So, I could drop it from here to get another formula, and then I could create another proof and drop it from here to get the other formula. But again, that's just for you to buy into the formula. Okay, see you next.